can do is you can, well, good thing I'm not recording that. Okay, so element and triangle L prime, N prime, N prime are similar. So you can label these 1, 2, 3, and 1, 2, 3. So then when you get down here and you look at those links, those side links, you just have to put the numbers that we labeled those vertexes. So which proportion must be true? So 4, side length of 4, like we said a second ago, is between 1 and 2. 5.4 is between 2 and 3. And so then on our smaller triangle, 3.24 is between 2 and 3, and y is between 1 and 2. So what you're looking for is for them to be exactly the same. So are those exactly the same? Do they equal each other? No. So then on B, 4.68, that's between 1 and 3. And then x is between 1 and 3. Then 3.24 is between 2 and 3, and 5.4 is between 2 and 3. So are those exactly the same? They exactly equal each other? Yes. So we can go ahead and circle that. So then on number 2, quadrilateral QRST and its dilation, quadrilateral Q prime, R prime, S prime, T prime are shown below. So that QRST, the bigger one, that's our old, or your pre-image. That's the first one. So then the ones with little hash marks, we know that is our new image. So which statement about quadrilateral QRST and quadrilateral Q prime, R prime, S prime, T prime is true? So kind of like what we did on that dilations work page, we can pick 1 point from each of those. So say we can choose R. So what's your old R? What's the old point for R? 8, 2. So then find R prime. Good, so 4 and 1. So then we can take one of our new points and divide it by one of our old points. So we can either take 4 and divide it by 8, or 1 divided by 2, which that would be our answer. So the scale factor is 1/2. So the answer choice is A says the side lengths of quadrilaterals Q prime, R prime, S prime, T prime are 1/2 the side lengths of QRST. Is that true? What did we just figure out? So then B, the side lengths of quadrilateral Q prime, R prime, S prime, T prime are twice the side lengths of QRST? No, because it got smaller. Then C and D, the angles of quadrilateral Q prime, R prime, S prime, T prime will be 1/2 the angles of quadrilateral QRST. So even though we found that vertex, we used that 1 point. Remember with dilation and all of these transformations, the angles don't change. So whether it gets bigger, whether it gets smaller, your angle measurements don't change. Just the side lengths change. So it can't be C and it can't be D. Okay, number 3, the graphic below shows triangle ABC and its dilation, triangle A prime, B prime, C prime, with the origin right in the middle as the center of dilation, and the scale factor is 2. So which statement is about both triangles is true? So A says the corresponding angles of triangle ABC and ABC are not congruent. So congruent means same. So what we just talked about just a second ago, did the angles change? No, so the angles should stay the same. So this is saying that they're not congruent. So A is out. The angle measures always stay the same. Then B says the corresponding sides of triangle ABC and A prime, B prime, C prime are congruent. So they're saying that those side lengths are the same. Is that true? Think about if you're looking at from A to B to the dilated A to B. Are those going to be the same measurements? No. So they would not be congruent. They wouldn't be the same. Then C, the corresponding angles of triangles ABC and A prime, B prime, C prime are congruent. What do you think? That sounds pretty good because we said the angles don't change. The angles stay the same regardless of if they get bigger or if they get smaller, just the side lengths are changing. So then D says triangle ABC is congruent to triangle A prime, B prime, C prime. Remember, congruent means same size, same shape. So that would not be true because our triangle got bigger. So it's got to be C. Just kidding. Number 4. Go back. The coordinates of vertices of rectangle PQRS has vertices P, -3, 3, Q, 6, 3, R, 6, -3, and S, -3, -3. If rectangle PQRS is dilated by X and Y, X, 1/3 X, 1/3 Y to create rectangle P prime, Q prime, R prime, S prime, which set of coordinates represents the vertices of our new image. So just like on that paper we did, these are our old points. They gave us basically the scale factor. So always that number that's being multiplied by X and Y, that's your scale factor. So we're looking for the new coordinates. So we're gonna take the first set, the old set, and multiply each number by 1/3. So -3 times 1/3. So it should be -1, and then +3 times 1/3 should be +1. Okay, so the new P should be -1, +1, and really there's only one answer choice that tells us that. If there were 2, we could go ahead and try Q and multiply each of those numbers by 1/3. But